Assalamualaikum and hi everyone. In this video, we are going to learn about Hess's Law. At the end of the lesson, students should be able to state Hess's Law. This Hess's Law was introduced by German Henry Hess in 1802 to 1850, and he is a Russian chemist. Definition of Hess's Law. When reactants are converted to products, the total enthalpy change is the same whether the reaction takes place in one step or in a series of steps. For example, delta H1, which is A to C, is equals to the summation of delta H2 and delta H3, which is from A to B and B to C. So this is the formula of how to calculate the delta H1. Enthalpy change, which is heat release or absorbed during a chemical reaction, is independent of the route by which chemical change occurs. Let's look at the example. This is the equation for delta H1. This is the equation for delta H2. And this is the equation for delta H3. So from the equation given, we can construct an energy cycle method. So this is the first equation, which is carbon plus oxygen that produce carbon dioxide. So the delta H1 given is negative 394 kJ per mole. So we assume that this is a root 1. Then this is the second equation, which is carbon plus oxygen produce carbon monoxide. So the delta H2 is equals to negative 11 kJ per mole. And this is the third equation, which is carbon monoxide plus oxygen that produce carbon dioxide. So the value for delta H3 is negative 283 kJ per mole. So from this energy cycle construct, the delta H1 or the blue one is a root 1. And the red one here, we assume that as a root 2. So as we learned in the previous slide that the delta H1 is equals to the summation of delta H2 plus delta H3. So root 2 is delta H2 negative 11 kJ per mole plus with delta H3, which is negative 283 kJ per mole. So when we calculate, we get negative 394 kJ per mole. It is the same as a root 1, which is a delta H1. So that we can conclude that the total enthalpy change is the same for both roots.